This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 8 of graphing cosine functions, and in this video we're going to graph y equals the cosine of x plus 5 pi over 6 plus 1. Alright, over here on the right, remember these are the 5 key points for just y equals the cosine of x, but we're doing y equals the cosine of x plus 5 pi over 6 plus 1. Right, again, notice we just have a 1 for the coefficient of x, and we also have a 1 for the coefficient of the cosine. So if I were going to state what the amplitude is, it would just, we know it's going to be 1 because of this 1 here, and the period is still going to be 2 pi. Okay. But we have a phase shift here because it says x plus 5 pi over 6. And to get the phase shift, remember what we do? We take what's inside the parentheses and set it equal to 0. So if we do x plus 5 pi over 6 and set it equal to 0, and then solve for x, this tells us two things. It's going to tell us our first x-coordinate of the key points, and it also tells us that the phase shift is the absolute value of that, 5 pi over 6. The negative sign tells you it goes to the left. So we could say that the phase shift is 5 pi over 6. Whoops, hold on. 5 pi over 6 to the left. Okay. Another thing we know is that this plus 1 at the end tells us there's going to be a vertical shift. So the vertical shift, it's plus 1, so it's going to be going up 1 unit up. You could say here 5 pi over 6 units to the left. Usually I just say units also. All right. So we've got our first x-coordinate. That's going to be, I'm going to call that x1 so we know what I'm talking about. That's negative 5 pi over 6. And since I have a period of 2 pi, that means I'm going to add pi over 2 to get the next x-coordinate. So if I take negative 5 pi over 6 and I add pi over 2, I will get my next x-coordinate. And let's see, if I get a common denominator, I'll have to multiply this by 3 over 3. So basically what I'm doing is I'm adding 3 pi over 6 to get each next coordinate. Okay, so let's move this temporarily. So if we've got, what does this give us? So we have negative 5 pi plus 3 pi. That's a negative 2 pi, right? Negative 5 plus 3 will give you the negative 2 part, right? So negative 2 pi over 6. So to get my next one, I'm going to just keep adding this number, right? You just add 3 pi over 6 to get the next one. So my x3, could you do that in your head? What's the next coordinate going to be? If I add 3 pi over 6, I should get pi over 6, etc. So this is how you can get your 5 key order pairs. So let's go to the next screen and write those all down, and then we'll figure out what the y coordinates are. All right, so we've got x is the first coordinate. Remember, we had negative 5 pi over 6. We added 3 pi over 6. That's the same thing as adding pi over 2, right? To get the next x coordinate, we added 3 pi over 6 again to get the next one. So if we add 3 pi over 6 again, we get 4 pi over 6. And if we add 3 pi over 6 one more time, we have 7 pi over 6. So those are going to be our x coordinates. And this was the function we're graphing, right? Y equals the cosine of x plus 5 pi over 6 plus 1. So my y value is going to be what? Well, it's the cosine of what's in parentheses here, which all we need to do is remember these key y coordinates, right, for just the cosine, because we already adjusted for this negative 5 pi over 6. Remember, when you put negative 5 pi over 6 for x, you're really just computing the cosine of 0. That's why that works. It's just a reminder. And then we're adding 1 to it. So we've got these y coordinates. That's the cosine part. 1, 0, negative 1, 0, 1. And then what happens? I have to add 1 to each of these. And that gives us our y values. 2, 1, 0, 1, 2. Now remember how this goes. It starts with one number and then to another number, and then it starts going back up again. So 2, 1, 0, and then kind of back up 1, 2, right? These should sort of match. So now we've got our 5 key points. So now we're ready to graph. All right, so are you ready? You might notice it takes about a page to do each problem. All right, so here's our function, y equals cosine of x plus 5 pi over 6 plus 1. We already determined the amplitude, the period, the phase shift, and the vertical shift. We also didn't write this down, but the domain, as usual, is going to be negative infinity to infinity. And the range, if we look at the picture here, we see it goes between 0 and 2. Okay. So, ready to graph. Now, for the x-coordinates, this is the important part, to know where to put your y-axis and how to label it on here. Notice it goes from negative pi over 6 to 7 pi over 6. I think of that as going like from negative 5 to 7. So I'm going to put the y-axis a little bit to the left. And also I notice it's the range going from 0 to 2. So basically I need more room above than below. Okay, so let's go to the left 5. 1, 2, 3, 4, 5, and we'll call that negative 5 pi over 6. And to the right, 1, 2, 3, 4, 5, 6, 7 pi over 6. All right, you can make some more markings, that's fine, but we need at least to have that much there. And on the y-axis, we need 1, 2, 3. Okay, you could also put markings down here, but that's clear. All right, so we're ready. So we've got negative 5 pi over 6, 2. So we go over to 1, 2, 3, 4, negative 5 pi over 6 and up 2, and that's our start point. Negative 2 pi over 6, 1. That'll be right here. So we're going up 1 unit. Pi over 6, 0. So that means 1 pi, right? 1 pi over 6. So that's right here at 0. That's our low point. 4 pi over 6, 1. And 7 pi over 6 back up at 2. And that is our one cycle, one period of that function. Remember, it kind of starts going down again at that point. And so there we have a rough sketch. Now notice the vertical shift is up 1 unit, so it's like instead of going, right between the negative 1 and 1, it goes between 0 and 2, so it's like the whole graph was sort of picked up a little bit. You could think about it that way. And that's our graph. Try it all by yourself now. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.